Hello and welcome back. My name is Corey. You're my rubber ducks for the evening. And this is the series where we are creating Tang, a programming language from scratch using C++ and fundamental tools, all in a terminal window with Vim. And it's been, what number are we on? 35, I believe? Episode number 35. That's made some pretty good progress. And what did we even do in the last episode? That was a short one. We added the ternary expression to our language, and that's good. And this episode, whatever, is a little different. And that is what we're going to be doing is we're going to make our language slightly more resilient, maybe. You see, here's the problem. We've been able to explicitly define the size of our integers that we wanted. And we've been using int64t. 8 bytes. That's a lot. That's a lot of space for an integer. Well, we can do that. The C++ standard allows us to explicitly define the size of the integer that we want to use. The problem is the floating points. And we chose one that would work on my system and probably yours as well if it's a 64-bit system. But if it's something else, that could be a problem. So what I've decided is we're going to write some preprocessor directives and make it so that we use the size that is appropriate. How about that? And then if we've got time, some macros that would also make our code a bit cleaner. Let's see how this works. Okay, see how much we get into. Big disclaimer: I am not a guru at these. It's really metaprogramming. Not getting into the templating stuff, but at least with the macros. And so this is going a little bit outside of my comfort zone. As always, nothing up my sleeves. The last thing I did here was to do the commit for episode 34. There we go, tagged. It is up on GitHub as we speak. And if I say git status, there's no code changes. Yeah. So let's jump in. What we're going to be doing is, first of all, there is an include macros, and we haven't really been using it. In fact, the only thing we had was this unused thing, and we don't need that anymore because we've got this other way of specifying that something is unused. So I think we can get rid of this. And now what are we going to do? Well, namespace Tang. We want to be in the Tang namespace. And now we're going to define the size of integers used by Tang. And with that, we'll say using, and we will call this integer underscore t. I think that will work. Integer underscore t. And that will equal, and before we've been using, oh, no. You see, the problem is we use both unsigned and signed. So, I'm arguing with myself. internally. And the thing that I'm looking at is, do I want an unsigned integer to look like that? That makes sense, but it's kind of weird that the integer itself starts with a capital I. I do want these to be distinct. Of course, they're in the namespace. You know what? Okay. If I just give it a lower space, there is no other type called integer t. So this will be an int, and I'm going to change it. I'm going to say an int 32t. Okay? Why? Because of, and this will be signed integers. Okay. The reason is because as I make this change, if something's going to break, I want it to break. And it to be obvious. We've got all these tests, something will catch it. Okay, now for unsigned integers, we'll just say a u integer underscore t. That should be fine. And now comes the hard part. We have to define the size of the float. We can call it float underscore t. That should be fine. But what size? And if I pull up, do I have it still? The documentation, we've got the C++ reference of the fundamental types, and we have guaranteed sizes for integers, but not for floating point. And what are our options? Float, double, and long double. And we're not guaranteed to what they might be. So what we're going to do is, can I do it like this? If so, the if preprocessor, from what I remember, can't compare strings, but it can compare numbers, and it can do a size of integer underscore t is equal to size of float. Then it'll just be a float. Elif not okay. So double, and now long double. I don't know of a better way. We'll see if this works. First, make, really? There we go. Make test watch does anybody pound include macro? We're about to find out. So macros.hpp. Okay. Oh boy. who all is going to use this. We're about to have a big period where nothing compiles, okay? And to do that, we need to include, and I'm going to pull in all of the AST nodes. And let's start off with this does not reference. Oh, that's what I can do. So include, you know what, here, let's do that. Clear git grep -in, and I want to know everyone that uses an int 64t. That will also capture the uint 64t. So it's just integer. Oh, there's a computed expression, integer, and then stuff in program. Okay. That's interesting. AST node integer. AST node integer. Where is that? Number 12. And what we're going to do is do a %s of int 64_t, and that's going to be Tang integer t. That should work. Okay, now something tells me in the double, AST node double, oh, float, AST node float, that's 7. I'm going to need to do the same thing, but in this case, I'm going to need to change double to Tang : float_t. Okay. Is that all of them in the AST node? Okay, well, we'll keep going. Let's edit the we're in includes, computed expression. We can do float, that's fine, because we're going to need so I think computed expression will tell it to #include macro. Yeah. So we'll do that in just a moment. So let's, this is for the float. There. We did it 3 times. Edit the include for AST node float. No, we just did float integer. And now we need for this one oh, did I already do this one? Oh, it should have been, we should have edited the include computed expression integer. That's all right. Got it. Now, we might as well edit the program sorry, this is the include program.hpp, and we need to first do the uint64t. We're in an HPP, so it needs to be uint integer 64t. And all of these are uints. Okay. Now that I've done that, over here I'm going to rerun my git grep and nothing shows up. And if I look for uint64t, nothing shows up. And if I look for double, this should be fine. Wait, computed expression is equal double. The equal and the double equal should be fine, and the macros, of course, it's fine. All right, so I think we're okay with the include files. Now comes the big one. Let me just run this. First of all, git grep double. Let's go for the int64t. Oh yeah. And look at these. These are all AST node, and then there's a few computed expression, and then the program execute and program.cpp and program dump. Okay, but most of them are AST nodes, and so we've just got to work our way through this. Okay, so source AST node star and source computed expression we know we're going to have it for a float, for an integer. Computed expression float, source computed expression integer, source program.cpp, source program dump, and source program execute. 22. This is fine, sure. So we're going to start off of the uint64t. I don't need it to be Tang. I can just call it integer underscore t. Okay. I need to do it again for an int64t to become that. And now I need to do it lastly for a double. So these are the three that need to happen. And I'm just closing them. Okay. Always do the uint64t first. And now the int64t. I'm sorry, this is going to take just a little bit of a while. You know what? I think, okay, so the float's going to have the double. But I was going to say, I may just not do the double or the regular int, just the uint on all of them. Do the uint on... Oh, this is the computed expression. Okay. Why is this? Because I'm in the middle. Okay. Let's go to buffer 2. This is a binary. Sorry, it should only need the uint. Integer. I will need the uint. Oh, I'm in a computed expression. So the int and the float. Program. This could have all three. The uint first. The int. And double. Dump bytecode. Again, could have all three. Uint first. Followed by int. Followed by double. Program execute. That's fine. Uint first, int, double. AST node string should only have the uint. AST node print should only have the uint. AST node integer should have the uint and I don't think it's going to have the int. Oh, it did. Good thing. The if else should only have the uint. Identifier should only have the uint. AST node 4 should only have the uint. Node float should have the uint, and it should have the double. There we go. The do while should only have the uint. AST node macros.hpp. It needs to be included somewhere. Okay, now the uint. There we go. Node cast should only be the uint. Boolean uint block uint okay. Let's go back over here now and do our git grep for int64t. Doesn't exist. How about our doubles. The Boolean is fine. The garbage, that's fine. Okay. Did I change too much? All right, coming back to this. Sorry about that little delay. That was annoying because, quite frankly, I remember trying this a long time ago and knowing it didn't work, and I just kind of forgot. So here's what we're going to do. We're going to put a static assert that size of integer t is equal to size of float t, and integer and float must be the same. Okay. Integers of, and this is of signed integers. Now, what is it not like? I don't know. Okay, so program.hpp needs to include macro. So include program.hpp needs to pound, well, if it includes AST node, it'll get it. Include AST node, because it should be included in this. Okay. I should have looked at my time just so I know where to jump to. String. Okay, so edit the source for, what is this? AST node string. Getting there. Line 34. There we go, just do an explicit cast. And this is not liking something. So computed expression the computed expression needs to pound include the macro. Okay. That should be under includes computed expression.hpp. Of course, you know what this means. I'm going to have to add it to everything in the make file. Okay. So this is in computed expression float.hpp. Because that should not have been changed. That's fine. Nope. Include computed expression float.hpp. Double. Okay, so this is because I never did anything with garbage collected HPP. Okay. Or is it computed expression Boolean? Maybe that's it. Edit source. Computed expression Boolean. Line 50. Float T. This is the same thing, so let's go back to the edit the included computed expression float, because the is equal, oh wait, no, that's right. Computed expression float. There we go. This one should still be a double. Nope. The is equal should actually be an is equal. I mean, should actually be the float T. Okay, I was wrong. So on the include computed expression float is equal, and that means I'm going to have to change it in more than one place. It says it's an override, so if I edit the include for computed, this is computed expression. Tang float t, and for the is equal of the int should be a Tang integer t. It's probably going to tell me it's missing some stuff now. This is in the computed expression. So edit the source for computed expression, line 32. Yeah, this should be Tang what did I call it? Float t, and this should be Tang integer t. Yeah, that's what I called it. Okay, this is fine. In computed expression, integer is equal. These the same way. Integer t. Now in the dump bytecode. Okay, so edit source program dump bytecode, line 117. I'm probably going to have the exact same thing. So this size. Oh, okay. Bytecode is a bunch of unsigned integers. Same thing in program execute. Program execute, line 159. Just do an explicit cast. All right. Undefined reference to ASC node float, making a double. Okay. So that means the include for AST node float yeah. source AST node float. They should both have the float t. They do. Okay, so I'm doing something wrong. What am I doing wrong? Well, Corey, anytime you get a weird thing, make sure it's really something that's messed up. Remember, I haven't added the macros as a dependency for everything, so okay, good, different errors. Okay. So in the include garbage collected, we shouldn't have a double here. We should have a float t and an integer t. I'm going to need to edit the source for garbage collected and do the same thing, because otherwise it's gonna integer t float t. All right. This is also in it's saying it doesn't know what to do. Is that correct? It's saying it doesn't know which one to use. So test source no include tang.hpp and oh, 9. No, Tang. Or is this just in the garbage collected? Is this? Yeah. I mean, I thought I knew what the problem is. Oh, wait. That's not the first error. Okay, always go for the first error. So what are we compiling? Our test. Okay. Ambiguous for does not equal. Test. Yeah, B17, there we go. It's because it's thinking that this is... No, that shouldn't be right. Yeah, it's reading, I think, all of these because it's not the right type. I just want the first one, though. The not equals. It doesn't know which one to choose. It's the not equals, and it says it's from line 30. So it's this negative 42.5. And I'm wondering if I say this is a float t, CPP line 28. Now line 35, which is another float. Okay. So what I think is happening is (42.0) close with a float t negative 42.0 close. All of them. Okay. I want to do it again, but this time with a 42.5. 42.5. Do it again, this time with a negative 4.2. Negative 4.2. Do it again, this time with a regular 4.2. It's okay, I'll fix it in a moment. Do it again with the 3 point. Just looking for floats at this point. Do it again with, how about a 0 point? 0 point. Do it again with a 0.2. Nope. Don't do it on the point 2. Okay, so let's do some cleanup. I don't know what that was. That would have been a 0.0. Okay. Say, Corey, do we really have to do this? Well, no, but I kind of want to. Should probably, do something along the way and see. Oh no, oh no. What was this? That was a substitution gone wrong. What's the next one? $157. Okay. I just lost it there. I tried to hit end and I hit page down. There. Whatever I did on this one, I messed it up bad. See, and now I'm thinking, well, did I get these correct? Should they be a 3-point maybe? We will know when we... There we go. When we look at the diff, which is why we have a diff. Right. We missed a few. $712. We weren't down that far yet. That's why. That should have been a point. Almost there. 154. Missed one. $700. Missed one. Okay, now we're back to this. On line 150, we need this float T. To the modulo. Wait a second. This says modulo, but all these are addition. Did I never do the modulo? Let's check on that. For right now, let's go ahead and we'll finish these, looking for floats. Where did I miss one? 512. Okay. Well, we've broken some stuff. Ooh. Number 65. Whoops. Wrong screen. Why did that fail? Are all of these string failures? That one's not. That's 154. Yep, that should be 1,000. Okay. Okay, string failed, string failed, string failed. Line 700. Should be 100. I remember writing this one. What else? That was a string failure. This is a string. This one. 537. Okay. That was 537. A string failure. This one, 510. Okay. That's a number failure on 215. Should not have compiled it, because now I've got to look again. String, string, string. That's a string, string, string. That's a string, string. Okay, all of the rest are string failures, which means we're not converting our strings correctly. And so it's probably going to be in either the encoding. So I tell you what, let's go. Well, it'd be hard to tell. That's okay. We'll figure it out. First, let's look at the. Would it be the include? No, the source for the AST node string. We want to see what it's doing when it is compiling the literal. So it's putting in the length. That's fine. So to pack them in, what is it doing? temp is the number. For each character, we shift it left by the size of. We can do this is in fact possible, an or equal of this val sub I. And what is val? Oh, it's the character. That's fine. And then if I mod that is equal to the size of this minus 1, I don't have to include these, but I do prefer. I remember even thinking this when I wrote it, that I should include. If I is equal to, if that's a true value, that's what that's saying. I think that is correct. So let's go now to the source, edit the source program execute for the opcode string. Hey, here we are. Okay, so the bytes is equal to the ceiling of that's okay to stay a double. And we construct the string. How do we do this? So for each one of these, is this the problem? If I, which is the byte that we're on, times 8. Plus j is less than size, then wait, is that right? Yeah, that's what's funny is that will probably actually fix it. No, I think actually this one, it is. Okay, this is why you shouldn't write things as cleverly as possible. This a bytecode of the PC plus 2 plus I, that's whatever byte I'm on, shifted left by why is it 8? Because J is the byte that I'm on. And so eight is bits, but this should be size of U integer T. It's still broken. Wait. That one's not a string. .308. Pardon me. They are strings. So we don't know if the problem is in the storage or in the dumping of it. I really think it's in the loading it. So I'm going to double check this. Bytes is the size divided by the size of integer, but the ceiling of it, that's fine. So less than bytes. And for each byte, that's to go through each byte of the whatever's in there. Okay. We're going to have I times plus j is less than size. That should be fine. Okay. So temp, which is a string, is plus equal to, this is going to be a character, right? Two plus I. That makes sense. So I'm jumping forward to whichever byte. Because bytecode of PC, yeah. PC is the op string. PC plus 1 is the size. Plus 2 is the first character of, well, the first container of however many bytes. This is 4 bytes actually. Plus 1, or plus I, and I starts off at 0. So, okay, so I've got that as a uint64t shifted left by 8 times the size of u minus 1. Earlier it was 7 minus j. So now we just don't know if... Okay, so I want to look at the dump as well. We're in 13, it's in 12. Okay. B12. This needs the same treatment. Okay. These are the same. Now, the test is in 17. And we're just E17, okay. And the last one is on line 722. Okay, and that is this P8. So we're going to cout P8.dump bytecode. And we should get something that says hi. We do not. So it's either in the packing of the values. So let's go back to the string. We did have to make those changes on the execute, even if the string part is still messed up. So the string 4. There we go. I think that's going to be, this should be size of u integer t. That's just eyeballing it. That pretty sure that that was wrong. Still not right. Okay, look at this closer. Opstring, u integer t, this val length. I don't think that's the difference, but okay. Temp. That should not be size of u integer t. That should just be shift left 8. Because you only shifted over 1 byte each time. Hey, what do you know? We've only got one failing now. Okay, that's fine. Always glad to fix stuff like that. Let's go back to the test. Where is that cout? There we go. And now go to 679. Oh, yeah. That will probably do it. If there's no bytecode, that means there was a compile error. Yes, I know I'm not executing it. I'm seeing if there's a... Yeah, there's a syntax error. Found it. Segmentation fault. Probably because I'm asking for the result and trying to compare it when it doesn't exist. That's it. It compiles. Yay. Okay. Now, program.hpp. What did I do there? Don't know what it did. All right, now let's find the unintentional changes, unintended changes. Yeah. We're going to redo this anyway, but we want to see the git diff. There we go. Okay, macros. That looks correct. That all is correct, correct. 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 Okay. All these follow a similar pattern, so we're just kind of skimming through it. And again, you may say, Corey, was it worth it to go through all of this? I think so. One of the big things, we're in the ASC string compile. Is it also? Yeah, and no, the dump is fine, but the compile. Yeah, we used to have size of uint 64T, and it just so happened to be an 8, and so it worked. That's why, yeah, that should have just been 8 because it's 8 bits. Anyway, okay, so on this, the point is if you want to be able to run on a different architecture, maybe you need it to run on a 32-bit system or a 64-bit, or maybe we find that 64-bit instructions take up way too much space. Okay. That can be a fine-tuning thing, but to do this later would take even more work. It'd have been good if we had just done it from the beginning. We didn't know it then, but... Excuse me. And now as we're looking through here, in our tests, because the changes are in pairs, something should stand out if we accidentally changed it, because it'll either be in a group of 3 or a group of 1. That one stands out right there, and that is on, well, line 211. So not quite 211, one past it, but it is, we did originally have one more pair of parentheses, and I'm happy with that. That's fine. Okay, I mean, adding that one back. Ah, so that should have been a point. I guess it doesn't matter, but I don't want to change it if we're not needing it. So 670. All right. That's it. Make clean. Make test. That was huge. That was big. And if this compile goes according to plan, we're going to commit this. Well, almost. Because I want to... Okay, everything worked. I want to go back to the include macros and '64 64. Well, first of all, will it give me an error? Yep. Integer and float sizes must be the same. Will it work if I go back to doubles? If I go back to 64-bit everything? The last thing is, remember, we need to add macros as a dependency on everything. Okay. Which one does it not like? You're not going to believe this. Had to add these. And I'm not going to try to take a shortcut. Just get it all on the screen. There we go. By the way, no, I don't like the fact that we're having to do this. Oh, we never fixed the modulo. That will be that needs to be a separate commit, but it does need to happen. Okay, we're getting there. have a repetitive strain injury by the time this is done. Trues and falses. Trues and falses. True, false, true, false, true, false. Should have some around the ternaries. Oh, that is the ternary. Okay. I think there's a way of doing that, where everything's in a row. I just don't know what it is. It's funny, as I'm going through these, it's like, oh, I remember writing this. I remember, and it's like, wow, we've done a lot of work across this. And I am thankful for the unit tests, really. Especially because, well, I mean, you saw it there with the strings. We could figure out that, oh, there's the exact same error in the exact same place. Or with the exact same type of data. This is one where I think it was just that it wasn't starting from a clean make, and again, need to track down that missing dependency. Ah, we missed one. That is going to be, let's look in the include, computed expression float. And what is this? This is integer t. And we also need to do it in the source for computed expression float. So if you're wondering, Corey, why do you keep going back and why did you keep changing it to catch stuff like this? Oh, the integer as well. Edit the include for computed expression integer. Oh no, is equal. There we go. So that means I did it there, but I didn't do for the computed expression integer. The is equal here. Yeah. Okay. Now the make file. See, Corey, why are you adding it to everything? Because there's other things going to go into it, and we might as well do it now. Error, does it need it? We're going to add it because it's probably going to need it. Before we're done, it'll need it. Garbage collected definitely needs it. Program definitely. Dump bytecode. Yeah. Execute. Yep. Tang base. Sure. Parser. I think it could. How about the test? Does the singleton object pool need it? No. Does the, oh wait, just the regular. Just in case. Well, I'm wondering, does it actually? Yeah, I'll leave it there. Garbage collected, we're putting it in. Okay. One more time. Make clean, make test. Everything worked. one more time. It all worked. Okay, so now, which one do we go with? Well, I think that for right now, let's go with the let's go with the 32-bit. And then later we may switch back to 64 and check performance and everything. But for right now, let's go 32-bit. Why not? AM. And what is this? 32 bits. The last thing now is the modulo. This 167 to 187. 167, 187. We're going to change the plus for the modulo. There we go. Now none of these are going to be right. The 3 mod 5 should be a 3. 3 point mod 5 should be a 3. It should convert it to an integer, or is it going to say can't do that? I'm not sure. Yeah, let's just go from here. I meant to do make test dash watch. There we go. Why? Because we can just go down to the last one. Cannot modulo by 0. 9. This is correct. It should be an error. But I do want... I don't think that's the... So I think it should be... So if I were to do like a 13 mod 7 would give us a 6 mod 5. That should give us a 1. Okay. 183, that's this one. Should give us an error. Okay, that was correct there. This. Just cleaning up stuff here. Do I have any syntax errors? Okay, this one I expected to break, and I was just going to see what it was. P5. Okay. When modulating by a negative number, evidently it should be a positive number. Okay, that's just fixing the modulo tests to actually be modulos. Did I change anything? No. Okay. Modulo. Sure. Can't believe I had done that. Why didn't you let me know you're supposed to catch these things? Alright, rm-rf our docs. Okay, and do I still have this open? Yeah, I do. And now I'm thinking in our macros, of course, everything is including it, including a bunch of stuff over here. But we've got our type defs. There we go. And episode what? What episode are we on? Episode 35. Okay, so for episode 35. Oh, that was a big one. Well, we rewrote all sorts of stuff. Dash A, capital E, .035. Our message is... I mean, I could go in and say what all we did in this episode, but that's what commit messages are for, even though mine are kind of brief. All right. As always, we check. Not a lot of change. In fact, does it even say? It probably would have in the earlier one said how many lines were added and deleted. I don't think we had a large net change at all, but we did get some stuff done. And I know that this was a longer video. I'm sorry about that. It happens sometimes, especially since I think the previous two were quite short. But it needed to be done. That is, to realize that maybe on another architecture. Again, I wish I knew of a better way to detect what the size and automatically adjust. But from what I read, that's why people use pre-build systems, is because they will often figure that out and then like generate the correct .h file. I don't like that necessarily. So for right now, you would have to go in and change that one type. But we've at least verified that if you do change the type, as long as they are the same, all the code will work, and that is huge. So, all right. Well, having said all of that, we've come to the end of another video. Thank you for your patience with me, especially as I went through and just changed stuff, and then tracked down problems here and there. Only one really big bug. But anyway, thank you. And as always, hey, have a great day. Bye.